So today we're going to tackle 2.1.3. Let's get today's date on here, October 8th. We're learning some new angle pairs today. So two new angle pairs, alternate interior angles and same side interior angles. All right. I just want to review quickly. So far, we've got quite a few different angle pair relationships. Do you guys remember what complementary angles are? Could you draw a picture of complementary angles if I asked you to? If you've got some scratch paper handy, this might be a good exercise. Complementary angles, what do those look like? They're going to be two angles that add up to what? 180? No. Add up to 90 degrees. So if you ever end up with a situation where you've got a 90-degree angle, but you have two angles that are forming that 90-degree angle, those two angles would be complementary angles. Add up to 90. Supplementary angles add up to 180. Supplementary angles don't have to be right next to each other like these two are, but they can be. What do we call this big angle that is 180 degrees that those two are coming together to form? That's a straight angle. So we got complementary, we've got supplementary and straight angles. And I should have added this to our, let's go ahead and put this on here as well. Vertical angles was also part of that. Can you remember what vertical angles look like? Vertical angles are always formed in a situation where you have two straight lines crossing one another. I need you guys to stop, please. Thank you. You have two straight lines crossing one another, and they're always angles that are across from one another. This angle and this angle would be vertical angles. And what's special about vertical angles? Always, 100% of the time, they're equal to each other. All right, corresponding angles. I need you to be able to recognize corresponding angles. Corresponding angles happen when you have two lines being cut by a transversal. And remember, corresponding angles you can find if you pick one angle and you translate that angle into the other intersection. So if I just slide this angle right here up my transversal, it's going to end up right here. Those two angles would be corresponding angles. And what's special about corresponding angles? They're the same as long as the lines are parallel. So they're only the same when lines are parallel. I'm grabbing some tracing paper. If you guys don't have some, you might want some today too. Okay, so to all of that, we're adding on two more. Now, if you're starting to feel a little overwhelmed with the vocabulary, it might be a good time to create yourself a little vocabulary sheet, make yourself some flashcards, start doing what you need to do to make sure you can remember this, because throughout the rest of this chapter, pretty much every section here, we're going to be adding on between 1 and 3 more of these things. Okay, it's going to end up being quite a bit of vocab. All right, so let's go on to our lesson for today. If I can find it, here we go. All right, 2.1.3, more angles formed by transversals. So today I want to start off by talking about this word that I've been using and this symbol that I've been using. It's this idea of congruent. And we use this symbol for congruent. It looks like an equal sign, but it has a little squiggle over top. We're going to be developing the idea of what congruent means over the course of the first semester here. We've already talked about angles being congruent. So in our last, or in our 2 classes ago, we talked about how vertical angles are congruent. And when we're talking about angles, it just means that they're the exact same size. But angles are not the only thing that can be congruent. Sides can also be congruent. So when I look at this picture here, I can see by the tick marks that these 2 sides are congruent. When we say they're congruent, that means they're the same length. All right, so they're asking you to consider the isosceles triangle, and because of its reflection symmetry, which parts must be congruent? State the relationship using symbols. So they've already marked 2 of these for us. I'm going to go ahead and write this down. This side here we would call AB, and it's a side. It's a segment, so it gets a little bar over top of it. AB would be congruent to which other side? Do you want to say BC or CB? BC? Okay. Does it matter though? It doesn't. I usually will go alphabetical order if I'm thinking about it. So I probably would have gone BC also. All right. In order to do any more, we're going to need one more point. So would you please add a point into your figure? Let's call it D. It's going to be that point at the bottom of our triangle. Can somebody give me something else that would need to be congruent? It can either be a pair of sides or a pair of angles. If you're going to give me a pair of angles, please make sure that you're giving me 3 letters for each angle. Anybody want to be bold and give me something else that would have to be congruent in this figure? How about a pair of sides? Or a pair of lengths anyways. We said these 2 pieces were equal. Are there any other pieces in this picture that would have to be equal to one another? You guys looking at this piece down here and this piece down here? Yep, they would. Right? If this is symmetric, then those 2 pieces would fold right on top of each other. Let's go ahead and put a tick mark here to mark those congruent as well. And let's write down a congruent statement for those 2 pieces. Segment AD is congruent to segment DC or CD. It really doesn't matter. That's all the sides that I see. Do you see any angles that would have to be congruent also? We know a couple because of the whole isosceles triangle thing. Isosceles triangles not only have 2 equal sides, but they have 2 equal angles. You want to give me an angle pair? Which 2 angles would have to be equal? Say that again. You said ABD. That's this one up here. And what was the other one that you said? DBC. That would be this one right here. Do you guys agree that those 2 angles would have to be equal? If it's symmetrical and we folded them over, those 2 angles would match. So let's go ahead and put that down. Angle, you said ABD is congruent to angle DBC. And remember, when we're naming angles, it's that middle letter that's the important part. If you're talking about this angle up here, then B had to be our middle letter. Hang on just a second. You said BAD. Let me mark that. BAD would be right here. Okay, and BCD, you said C in the middle, so you must be talking about this angle. Those 2 would have to be congruent also. So angle, you said BAD. And then, what did you call it? BAD I got. BCD. If I had said BCA instead of BCD, would that be okay? Is that the same thing? BCA. That would be that same angle. Yep. So the important thing that C is in the middle, and that B and whatever other letter I choose, one of them is on this arm of the angle, and one of them is on this arm of the angle. So I could go with D or A interchangeably there. Any others? Yes. BDA is this one right here, and BDC. And can you tell me something more about them than that they're just congruent? They're right angles. How would you justify to me that these two angles are right angles? Someone give me a good vocabulary term for this angle pair right here. Notice that they are forming this straight line here. These two angles are, starts with an S. They are supplementary angles. Would you agree that these two angles are supplementary? And supplementary angles add up to 180. And if they have to be equal to each other and add up to 180, how big is each one of them? 90 degrees. So these two would have to be equal to each other as well. In fact, they would both have to be 90. So I'm just going to go ahead and write that angle BDA is congruent to angle BDC. This last piece I'm going to tell you is going to seem kind of weird to you, but we will actually use it in the second semester when we get into proofs. At a certain point, we're going to look at this picture and we're going to say that BD is congruent to BD. Why? Why would we ever do that? Obviously, something has to be congruent to itself, right? There's this thing called the reflexive property, and we will need to build evidence to prove something about triangles, and this will be one of our pieces of evidence. You don't have to worry about that for right now because it kind of really doesn't make a whole lot of sense right now. Okay. So I would like you guys to focus on the next question at hand. We're focusing on this picture now. And we're trying to say something about angle B. Oh, I missed an important piece. Could you guys go ahead and put a 48 in the diagram in the right spot? It says that A is 48 degrees. So go ahead and stick a 48 in here. They want us to say something about angle B. Now, I bet most of you could guess how many degrees B is. Do you feel confident you could guess how many degrees B is? What would you guess? You think it's going to be the same? It looks like it's about the same size, doesn't it? We could get out tracing paper and trace it, but we don't want to guess in this class. We want to be sure. We want to justify. So what relationships that we have learned already could we use to justify that B is also 48 degrees? So we do have parallel lines. That's key because we learned something about if lines are parallel, then what did we write in our notes yesterday? If lines are parallel, then corresponding angles are congruent. Can we use corresponding angles here? Does somebody need to silence their phone? Feel free to take care of that if you need to. So where would my corresponding angle be? Is A corresponding with angle B? No, A is not corresponding with angle B. A is corresponding with, if I slid A down this transversal, A would be corresponding with this. So I know that this is 48 because the lines are parallel and those are corresponding angles. Could you guys please label corresponding angles and draw me a couple arrows here so we know that those two things are corresponding angles? So great, you notice that the lines were parallel. That was key because if the lines are parallel, then corresponding angles are congruent. Now, what can I do to relate this 48 with the B? What's special is going on here in this situation? We got 48 and B. These two would add up to 180, the 48 and the B. These two right here would. Those are making a straight line. So we could do this. We could say these two angles are supplementary. Do you want to go ahead and do that? You want to use these two angles here? These two are supplementary. They would add up to 180. Okay. So someone help me out. What adds up with 48 to give us 180? 132? Someone help me out. You guys got calculators. 132? Thank you. 132. Thanks. Oh, Maya. Okay, and let's label those two angles. What was special about them? These two angles were supplementary angles. We're still trying to find B, though. What relationship do we know that's going to link B either to the 48 or to the 132? Yes? Great. This B and this 48, these are vertical angles, so we could just go ahead and copy it because we know that vertical angles are congruent. So we didn't actually need the supplementary angles, but we could have also gotten this 48 by the fact that the 132 and the B are supplementary angles. All right, so you guys guessed that 48 was, thank you, was the correct value, and you were correct, but it's important that as you're doing these, you're also using the relationships and practicing those. Okay, any questions on that one? All right. I just want you guys to go through these next three, kind of like we just did. And I want you to determine, are they congruent or supplementary? And what relationships that we already know could you use to convince somebody that they were? The relationships that we know at this point are supplementary, complementary, vertical angles, and corresponding angles. Okay, so just go through and state whether they are congruent or supplementary. Congruent or supplementary. All right, first pair here. Now, tell me what they look like. Do they look like they're the same size? I'd say no. This one looks like it's acute. This one looks obtuse. So they're probably not congruent. So by process of elimination, we think supplementary. But we need to be able to do better than that. So if I wanted to say that for sure that these were supplementary, what I could do is I could take that A and I could find its corresponding angle. I'm going to go ahead and mark it right here. This is A as well. Whatever this is, this has to be the same because they're corresponding angles and the lines are parallel. And then now I can see pretty clearly that A and B are going to be supplementary. So they are supplementary, and if you asked me to say why, I would say we've got parallel lines and corresponding angles congruent. For number 2, we could use corresponding angles again to move A or to move B. A is right here. If I wanted to find its corresponding angle, I could slide A along that transversal there. It would end up right here. So once again, we've used corresponding angles. And then once we get A into this position, what can we say for sure about A and B? I'd say they have to be congruent. I don't know why I wrote that out. I wish I'd just written the congruent symbol. And we've also used vertical angles to do that. A and B would be vertical angles. For number 3, again, use your corresponding angles to move A or to move B. I'm going to move B this time and find its corresponding angle. B's corresponding angle would be right here. And now that we can see A and B together at the same intersection, we should be able to look and say, oh, they're forming a straight angle pair, so those must be supplementary. And to do that, we use corresponding angles and straight angle pair. I want to focus on the one that we did up here next, and we are going to add another set of angle pairs and another property to our book of tricks here. So today, one of our learning targets was to be able to identify alternate interior angles. I want to break this term down into its two parts, alternate and interior. First of all, let's talk about interior. When we say alternate interior angles, we're always going to look for two angles that are between your two parallel lines. So between the two lines. Interior means inside. So if you look at the two angles that are marked in your figure here, notice that they are both inside of those two parallel lines. They're interior. Alternate means that they are on opposite sides of your transversal. So alternate interior angles, from now on, whenever we see these pairs, we can go ahead and name them. We can say these are alternate interior angles, and they have a property. What do you suppose is the property for alternate interior angles? Do you think they're equal, or do you think they're supplementary? If you had to guess right now, do these two look like they're equal, or do they look like they're supplementary? They look like they're equal. So alternate interior angles are congruent, but only if what? Same thing with corresponding angles. Corresponding angles are only congruent if the lines are parallel. So if the lines are parallel, then alternate interior angles are congruent. Let's flip over onto the next page. And let's complete the conjecture that you guys just told me. If lines are parallel, then alternate interior angles are congruent. Do you have a question?
No, I'm just reading the bottom.
Okay. That means congruent. And for right now, all I need you to know is that when we're talking about sides, that means they're the same length, and we're talking about angles, that means they have the same angle measure. We're going to expand on what congruent means later on, because we can talk about congruent shapes and other things that are congruent as well. But for right now, it basically means equal, right? It basically means they're the same size. Yeah. Thank you for that question. Some people don't like writing out a lot of words. We have this arrow notation that we can use instead of doing if-then statements. So if I wanted to shorten this, I could say lines parallel means that alternate interior angles are congruent. This is sort of an invisible if-then. If the lines are parallel, then alternate interior angles are congruent. Okay, so the question's asking how is it different from the original and what does the arrow mean? Do you guys feel like you could answer those two questions? How's it different? It's shorter, more efficient. What does the arrow mean? It means it follows that this is true. All right, so we're going to skip part D for right now and go on to the last part here. Any questions so far? All right, we're adding our last piece on here, which is same side interior angles. Let's talk about the different parts of their names again. So interior means same as it did before, between the two lines. But same side means, well, it means same side. I can't really think of a better way to put that. So this time we're talking about two angles that are in between the two lines, but they're on the same side of your transversal. Someone make a conjecture about these. What's the relationship? Do these two angles look like they're the same? Do they look congruent? Do they look equal? They don't look equal to me either. This one looks like it's smaller than 90. That looks like it's bigger than 90. So they're not congruent. Do they look like maybe they'd add up to 180? Could you convince yourself that these two angles would add up to 180?
Yeah.
We could do alternate interior angles to move this down to here, and then these definitely add up to 180. We could use corresponding angles to move this down to here, and these two add up to 180. They do add up to 180, so they are supplementary. So let's write ourselves an if-then statement. And I'm going to use arrow notation. This only works if the lines are parallel. So if the lines are parallel, then, and here's how I abbreviate these, same side interior angles are not congruent this time. They're supplementary. They add up to 180. All right, we're going to call that good for today. Does anybody have any questions? So we're going to skip the parts C and D. We may come back to those later on. What we added on today, so this is what we talked about at the beginning of class. At this point, this is what you're responsible for knowing. Supplementary angles are angles that add up to 90. I'm sorry, complementary angles are angles that add up to 90. Supplementary angles are angles that add up to 180. A straight angle pair like this is supplementary angles. Vertical angles look like this. They're across from each other and they are congruent. Corresponding angles are angles that you can move using a translation to move from one onto the other. And if the lines are parallel, they're congruent. And then we've added two more. Alternate interior angles, those would be angles that are between the two lines but on opposite sides. And those are congruent if the lines are parallel. And then we also talked about same side interior angles. Those would be two angles that are on the same side of the transversal, but still in between your two lines, and those are supplementary if the lines are parallel. All right, so our vocabulary list and list of properties is continually expanding, and it's going to continue to expand. As you're working through the assignment today, make sure that if it's asking you to explain why something is true, that you're using these vocabulary terms, because these are alternate interior angles, so they should be congruent. Because these are same side interior angles, so they should be supplementary. Okay, the rest of the time is yours to start on the assignment. Please let me know if you have any questions.